Hi everyone, my name is Amitesh and this video is a step-by-step tutorial on how to graph lines and also a general introduction to how to graph a function and what is the xy plane, what are Cartesian coordinates. So let's just dive right into it, and my goal is to really help you master this topic so you're confident with lines, graphing, and then you can move on to more advanced examples too. So the first thing is, what is the xy plane? Okay, so the xy plane is basically what is called a Cartesian coordinates. Okay, so xy plane is you have an x-axis which is horizontal, you have a y-axis which is vertical, and to specify a point in the plane you have to specify how far you're going either to the right or to the left, which is called the x coordinate, and how far you're going up or below, which is called the y coordinate. Now if x is equal to 1, so you can sort of draw this is like the number line. Okay, so I'm just going to show you some examples of points, but let's just label it first. Okay, so you've got 1, 2, 3, minus 1, minus 2, minus 3, and then on the y-axis you've also got 1, 2, 3, and you've got minus 1, minus 2, minus 3. Okay, now of course this goes on forever indefinitely in both directions, but we can't actually draw that on the board. But what we can do is with this picture we can label some points. Okay, so for example, suppose I drew this point that was just here. Okay, how do you explain what this point is, right? I've drawn it, but how would you communicate it to someone else in symbols? That is the idea of Cartesian coordinates. So here you sort of see that the x coordinate is 1 and the y coordinate is 2. Okay, so you would get the point 1, 2. That tells you that you've gone 1 unit to the right and 2 units up. Another example of a point is if you have this point here. Okay, what are the coordinates of this point? So again, you're thinking about to the right you've gone 3 units, that's the x coordinate, which is always labeled first, and then you put a comma to denote the y coordinate, which is you've gone 2 units down, so we put a -2. Okay, so we get 3 comma -2. Another example of a point is this point here, so I'm going to kind of draw it here. Okay, so what are the coordinates of that point? I want you to sort of mentally think about it. On the x direction we've gone -3, on the y direction we've gone -3. So it's going to be -3 comma -3. Okay, that's going to be the coordinates of the point. Now this is a lot like many other systems in math, like latitude, longitude, on the globe. You can specify points by latitude and longitude. In theory, we don't do that anymore because we have lots of cities and towns which we know by name, like Paris or New York or London. But you can also specify them with longitudes and latitudes, which is a coordinate that tells you how far it is. Latitude is how far it goes between the south and the north pole, and longitude is kind of east/west. Okay, so you can do it that way. And this is kind of evolved into this general system that you can specify inside a plane, inside a piece of paper, for example, you can specify where your point is. So let's do one last example, and this is going to be one of the most important examples, is what is that dot in the middle? So here, basically, it is x is 0, y is 0. So we just say this is the point 0, comma 0. Okay, so these are examples of what is Cartesian coordinates in the plane. Okay, so a quick introduction to that. Now we're going to talk about how to graph a line in the plane. Okay, so what is a line in the plane? So when we specify, when you try to graph something, so if you've seen functions, this is like graphing a function, but even if you haven't, we can kind of talk about this in a very simple terms. So if you have something like y equals to x, right? What does this mean fundamentally? Well, it means that you're trying to find all the points in the plane so that the x coordinate is equal to the y coordinate. That is what the meaning of y equals x is. Okay, so you're trying to plot all those points. Now, when you're trying to graph something like y equals x, what you're going to do is you're just trying to plot the points, right? So I'm going to give you kind of a picture of this, and you can use different scales, right? So here I'm going to, just to show you the picture, I'm including more points in this picture. So -1, -2, -3, -4, -5. And we can go in the bottom direction, -1, -2, -3, -4, -5. You can go in the top direction, 1, 2, 3, 4, 5. Okay, so here's the y-axis, here's the x-axis. It's always good to label. And now we want to plot all the points where the x coordinate is the y coordinate. And here is going to be an important point that I haven't included there, is you can have coordinates which are fractions or decimals, just like you can have numbers which are fractions or decimals. So typically, for example, if I did a point, typically we eyeball it. So if I had a point like this, right? What coordinates would that be? So, you just try to eyeball it and say, okay, it's maybe half between 2 and 3 on the x-axis and half between 0 and 1 on the y-axis. So you kind of say the coordinate is going to be 2.5, 0.5. And of course, you can be more precise. You can have a coordinate like here, which maybe could end up being pi, 0. Like it's pi units in the x direction on the right, and it's just on the x-axis, so its y coordinate is always going to be 0 because you're not going north or south. And now when you have y equals x, it's the same principle. You can plot some points, x and y are equal, so 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3, negative 4, negative 4, negative 5, negative 5. And you kind of see that, of course, when x is 1.5, y is 1.5, y is equal to x. So you can kind of go on plotting, but you sort of see that the more you plot, you're just going to get an infinite number of points, right? So whatever x value you have, you can find a point on the line where the y value is just whatever the x value is, and that is going to be y equals x. And here I say line because if you're actually going to just like keep plotting, you'll get a continuous collection of points, right? So this will be a line, and this is going to be the line y equals to x. Okay, so that's going to be how we graph that line, y equals x. Now, that's the first step of graphing a line. You've got that line down. Now, we can graph other lines, okay? And I'm going to do this in a different color. I'm going to use maybe, instead of this, I'm going to use blue. So what we can do is we can ask, what about the line y equals to 2x, right? Let's change it up. So here we're going to plot all the points so that the x coordinate times 2 is the y coordinate. Okay, so what are all the points so that twice the x coordinate is the y coordinate? Well, it's the same idea. Let's just think about it. If we have x is 1, then y should be 2, right? Because y is equal to 2 times x. So we can even draw a table. Okay, this is another way. In the case y equals x, it's just the same coordinate repeated. But if you have y equals 2x, it may help to just draw a little table. So here you have x and y. So if x is 0, y is 0. If x is 1, y is 2. If x is 2, y is 4. If x is 3, y is 6. It's always going to be y is 2 times x. So we can kind of plot it out. We can say when x is 0, you've got y is 0. When x is 1, you've got y is 2, right? I'm drawing some blue dots here. When x is 2, you've got y is 4. And you similarly get when x is minus 1, you've got y is minus 2 because it's twice x. When x is minus 2, y is minus 4. So you kind of see that the y value increases faster this time. In the line y equals x, x and y were equal, but now y is 2 times x. So if you actually try to plot the line, you're going to get something that is steeper. Okay, it's going to be steeper. This is going to be the line y equals to 2x. Now you can sort of imagine that if I had, y equals 10x, then when x is 1, y is 10, it would be really steep, right? So you're multiplying something by x. If the something gets bigger, it gets steeper and steeper. Okay, so this is sort of the general idea between y equals x and y equals 2x. Let's now plot y equals negative x. Okay, so let's play around with that. And I'm going to do it on this plot here. Okay, so just to kind of erase what we've already written, just to kind of erase these points and do the same plot. So what happens when y is equal to negative x? Okay, so I'm going to again do it with a red. So let's draw with a red line. So y equals negative x. So y is always negative x, right? So if x is 1, y is negative 1. If x is 2, y is negative 2. Okay, so that's the principle. So what we want to do is we just want to plot some points. We can again draw a table if you like, just to get the hang of it. So when x is 1, y is 1. When x is negative 1, y is going to be, when x is 1, y is negative 1. When x is negative 1, y is 1. When x is 2, y is negative 2, and so on. Okay, so we can kind of plot some points here. So when x is 1, y is negative 1. Okay, so when x is 1, y is negative 1, so we've got the point 1 comma negative 1 there. When x is going to equal to 2, y is negative 2. When x is equal to negative 1, y is positive 1. Okay, so we've got -1, +1. Okay, so these are going to be the points that we label on the line, and now we can just draw the line like this. We can kind of, oh sorry, we can, I've drawn it a little slanted, it should be straight, but that's going to be the line y equals to -x, okay? So that's going to be the line y equals to -x, and you see that it is what is called downward sloped, okay? The line y equals x is kind of sloped like this. Here the line y equals -x is sloped downward, okay? That means that when x increases, y decreases because of the negative sign, whereas here in these two lines, when x increased, y also increased. Okay, so there's the line y equals -x, the line y equals x, and the line y equals 2x. Now we're going to observe what happens when you have a line like 2x plus 3. Okay, how do you graph something like that? These are the general kinds of lines we get. Something x plus something, and I'm going to conclude the video by doing that. So let's get into that. So here what we're going to do is I'm just going to erase this here, erase kind of this, this figure, and talk about some lines that are a bit more interesting or a bit more complicated maybe. So let's talk about y equals to 3x, okay? And I'll have something at the end too, okay? So there'll be a surprise at the end, so watch for that. That'll be cool. But what we're going to do is that we're going to graph the line y equals to 2x plus 1, okay? Y equals 2x plus 1. How does y equals 2x plus 1 look like? So here's one way I like to think about it, and this is kind of the conceptual way of looking at it. So we can sort of graph the line y equals 2x, right? So we can sort of say, okay, 1, 2, 3, 4, 5, 6, okay, and then you have 1, 2, 3, 4, 5, 6, let's put up to 7, okay? Now, what happens is we can graph the line y equals 2x first. We know that. 1, 2, when x is 1, y is 2, when x is 2, y is 4. So you can kind of keep graphing that. So when x is 1, y is 2, when x is 2, y is 4, when x is 3, y is 6, etc. So you've got this kind of steeper line than y equals x that kind of goes like that. But now what you can do is what happens to find out y equals 2x plus 1? Well, the y value will always increase by 1, right? When x is 1, y is 2 for y equals 2x, but when x is 1, y is going to be 2 times 1 plus 1, which is 3. So we can actually plot it. All the y values are going to shift by 1 upwards because it's 2x plus 1. And actually that consistently shifts the graph 1 unit up. So we can actually derive it from the graph we have here. So let's do that. So let's actually even show a table. You know, when x is 0, y is 2 times 0 plus 1, which is 1. When x is 1, y is 2 times 1 plus 1, which is 3, and so on. When x is 2, y is going to be 5, etc. But what you can do now is you can actually draw, I'm going to try to do this in green, you just shift it, okay? So you just shift the line, or maybe I'll just do it in black. You just shift the line, which means that when x is 0, you've got y is 1. When x is 1, you've got y is 3. When x is 2, you've got y is 5. When x is 3, you've got y is 7. So you see that it's just going to shift up by 1, but it's going to have what we say the same slope, okay? So it's going to be parallel. The black line and the red line are going to be parallel. Just the black line is shifted 1 unit up, okay? And this is going to be the line y equals 2x plus 1. And for the red line, we're going to have the line y equals 2x, okay? So that's the idea. So this is kind of a cool way I like of graphing lines, is just simply kind of forget that thing you're adding and just graph the line, and it sort of depends. You know, if y is 2x, it's going to be slanted up. If y is -x, it's slanted negatively. You know, if y is -10x, it'll be slanted really like steeply downwards. But then what you do is you want to add on some number, you just translate that graph, you know, either up or down depending on whether you're adding by 1 or subtracting by something, etc. Okay, so let's do one example which is kind of a little bit like maybe tricky, and I'm going to show you some kind of moral from this, which is also an important moral. And the moral is that when you draw a line is determined by 2 points, okay? This is a mathematical principle. What it means is that if I tell you what two points on the line are, I can just connect the dots to draw the line, right? If you just imagine without the xy coordinates, if I just draw 2 points, there's only one line going through the 2 points. You just have to connect the dots. And you can't do anything crazy. Once you've connected the dots, you can't slant and zigzag. You just have to go straight. So there's only one line through 2 points. So to graph a line, you just have to graph 2 points in the line. So I'm going to use that principle to graph the following. So let's let's kind of do that here. Let's graph the line y equals to 3x minus 6. Okay, something a little bit more complicated than what we've seen. Let's try to graph what this is. So what it helps to do is, when you see the minus 6, you kind of know that you're going to get some big numbers maybe. So it helps to try to draw your scale a little smaller. So you can kind of have something like 1, 2, 3, 4, 5, 6, for example, and then you could do 1, 2, 3, 4, 5, 6, 7, etc. And you can do it in the other direction too. So maybe let's do in the other direction: -1, -2, -3, -4, -5, -6, -7, etc. Now what we can do is we can plot two values, and then we know we connect the dots. That's going to be the trick. So let's do that. So we have our xy table here. So I'm going to write it here, our xy table. Let's choose the favorite values that we like. So what are our favorite values of x? X is 0 and x is 1. They usually work fine. So when x is 0, you're going to get y is 3 times 0 minus 6, which is going to be minus 6. And when x is 1, you're going to get 3 times 1 minus 6, which is 3 minus 6, which is negative 3. Okay, so x is 1, you're going to get y is negative 3. You don't have to do more than that. You can if you want, but you don't have to. And here's why. So you know that the point 0, -6 is going to be on the line, because x is 0, y is -6. And you also know the point 1, -3 is going to be on the line. So let's plot those points and connect the dots. So when x is 0, y is -6. When x is 1, y is -3. So now we've done that, we just connect the dots. Okay, and you can sort of, so here's an important principle when drawing lines. I'm going to just touch on this and do more in another video, but it also helps to just see where the line cuts the y-axis and the x-axis. Okay, this kind of is important in graphical depictions of lines. So for example, when x is 0, that's when x is 0, it's on the y-axis, right? Because you're not going, 0 means on the x-axis you're not going right or left, you're just staying still. So on the y-axis you've got the point 0, -6. And when is y 0? That's when you're on the x-axis. Y is kind of telling you how far up or down you're going. So when y is 0, you have to solve the equation. Y is 0, well, the line is y is 3x minus 6. So that means that 3x minus 6 is 0. And if 3x minus 6 is 0, you're just solving the equation 3x equals to 6, or x is equal to 2. And so here you can see this is consistent with my graph. I knew to make sure that I was drawing correctly so that it goes through the point 2, 0. This is what we call the x-intercept, okay, of the line. It's when, or the graph, and this is what we call the y-intercept. Okay, so that's going to be a quick summary on how to graph lines. And I guess I just sort of gave you a quick overview of what are all the fundamental concepts. I hope this was super helpful for you and I was able to support you. Check out my videos on my channel. I have a video on functions. These are functions. Y equals 3x minus 6. X is the input, y is the output. And you can graph a lot of functions and they can be curvy, unlike lines, But a lot of the same principles like intercepts and graphing and thought processes, they just get more difficult, but they kind of are all based on this introductory material on graphing lines. So thank you so much for watching. Please like and subscribe. Spread the word to family and friends. If you found value from this video, it'll mean a lot to me. Just to subscribe helps you disseminate my videos to many people, because my goal is free accessible math education worldwide so everyone can love and benefit from math. And I want these resources to be available everywhere to everyone, and that's why I'm doing this. So by liking and subscribing, you really help motivate me and support my mission. Thank you so much for watching. I wish you all the best wherever you are. Please comment if you have any thoughts or comments. I'd love to hear from you, and I'm super excited to see you in the next video.